All right. This is 5, 7, and change of base. So in 1990, there were about 5.4 billion people in the world. If the population had been growing at 1.95% per year, estimate the year when the population will be 8 billion people. And so we got to set up our A of t is equal to A of naught or a sub naught times 1 plus the rate to the t power, to the time power. And let's start filling in the pieces we know. In 1990, there were about 5.4. That's our a sub naught. So 5.4 billion. And the world had been growing at 1.95%. So 1 plus 0.0195. And we need to figure out when the population will be 8 billion people. So how long of time needs to go by? Okay, so let's start messing around with this a little bit. First off, we're going to add these together, and we get 1.0195 to the t power times 5.4 is equal to 8. And divide each side by 5.4. Make sure you don't multiply it in, because remember, exponents happen first. We actually can't multiply this 5.4 in there. We're going out of the order of operations. But we can divide both sides by 5.4. And we'll be left with, let's see, what is that? I think it's 1.8. 1.48. So from here, head on up. 1.48 is equal to 1.0195 to the t power. Okay, and so let's take the log of both sides. We're gonna it's in exponential form. Let's change it into logarithmic form, and so we're gonna have log of 1.48 just taking the log of both sides is equal to, and we're going to leave it as base 10 right now. And as long as you take the log of the same base of both sides, it'll still be equal. So log base 10 of 1.0195 and to the t power. And we've learned, hey, if I have this exponent here, I can bring it down out front. So let me rewrite this line. We have log base 10 of 1.48 is equal to t times log base 10 of 1.0195. And just to kind of make the note here, and there's a reason I'm making this note, we could have taken the log of whatever base we want. Notice that we did base 10 here, but we could have done of e, of 4, of 3, whatever number you wanted to. It didn't make a difference, because we're going to take the log of both sides. We're kind of complicating it intentionally, and we'll see why in just a few moments. All right, now whatever log base 10 is of 1.0195, I'm going to divide both sides by that, so I'm down to just t. I'm going to divide both sides by log base 10 of 1.0195 and log base 10 of 1.0195, and that'll give me, let's see, that'll give us t is equal to log base 10 of 1.48 divided by log of base 10 of 1.0195. And let's go ahead and hit this into the calculator and see what we get. We'll have, so log base 10 of 1.48, 1.48 divided by log base 10 of 1.0195. And what do we get? Close parentheses. We get 20.300. So it's 20.3. This is roughly equal to 20.3. Now we're going to come back to this question in just a few minutes once we've learned what change of base is, but we kind of actually have just showed it here. So right now, there's that problem. We've now found what t is roughly equal to, and we'll be more specific in just a little bit. Hope that gets you started though.